Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, good morning. My name is Bayu Ishartono and this is my article review in course of current research in Applied Analytical Chemistry under supervision of Dr. Dwi Siswanta, Master of Engineering, Ph.D. Now, I would like to present the article review with the title Lignin-Derived Carbon Dot, Cellulose Nanofiber Films for Real-Time Food Freshness Monitoring. The outline of this review consists of the first one is general information of article. The second one is abstract. Number 3 is graphically ideas presentation, continued by contrasting literature and invention, result and discussion, and the last is inspirational implication from this article to my research topic. The first one is general information of article. This article has the title The Lignin-Derived Carbon Dot Cellulose Nanofiber Films for Real-Time Food Freshness Monitoring. This article has been downloaded from ACS Applied Materials with this TOI and include or belong to quartile 1, and also this article have the supporting information with this URL and received in August 2022 and accepted in October 2022. The second one is abstract. This abstract of this article consists of some keywords such as separation, lignocellulose, lignin-derived carbon dots, rhizometric fluorescent probe, cellulose nanofiber film, and biogenic amine detection. Based our review, I can conclude this abstract consists from some summary. The first is a simple, environmentally friendly, and long-term strategy for the separation, conversion, and utilization of lignocellulose component was developed. Second one, the recovered lignin had the potential to be synthesized into lignin-top carbon dots, or CDS, in fluorescent probe for detecting biogenic amines, or BAS, caused by food deterioration. Number 3, this probe responded to BAS in a sensitive, fast, and linear manner with a detection limit of 0.045 micromolar. Number 4, through oxidation and mechanical treatment, the residual cellulose with the crystal 1 structure was employed to the cellulose nanofibers, or CNFS. Number 5, in addition, CNFS were employed as a metric to create CDS CNFS films for real-time and food and visual food freshness monitoring. The last one, this study not only broadened the green and environmentally friendly utilization of lignocellulose, but also revealed the potential of CDS-based composite films in on-set monitoring of food quality and safety. Number 3, we can discuss about graphically ideas presentation. This graphically ideas presentation, we can begin from the improper handling of production, transportation, storage, and consumption of food can cause food safety risk issue. From this food safety risk issue, there are compounds such as biogenic amines, or BAS, as toxicology that can cause some toxicological effect such as headache, respiratory distress, heart palpitation, and several allergic disorders. So, in addition, biogenic amines uh, can can play a biomarkers for estimating the freshness and quality of some foods. So, to overcome this problem, we need some method. We need some method in order to developing efficient and real-time food quality evaluation method. Uh, One method can propose in this article. This is fluorescence sensing platform that synthesizes using greener rods from natural famous waste. The natural famous waste, such as cellulose from natural famous bed heads, became synthesized into carbon dots. The advantage, I'm sorry, the disadvantage of carbon dots from lignocellulose is low cost, and then I'm sorry, the advantages of carbon dots from natural biomass beds are low cost and then renewable, and biocompatible biomass carbon structure. In addition, enhancing fluorescent CDS, this article encapsulates CDS into cellulose nanofibers or CNFS because encapsulating CDS into CNFS have some advantage. There are high strength and then feasible modification and also controllable structure. So the greener synthesis of CNFS, uh, we can get some advantages such as modification of hydroxy group in by oxidation, esterification, esterification, and co-polymerization. Second one is a green deep electric solvent or DES. The third is fabrication of isometric fluorescent probe, and the last is integration fluorescence sensing platform using smartphone. So we can make an intelligent food packaging from CDS-based composite films. As illustration, we can see in the figure one, this is the preparation and application of the probe in detection of biogenic amines. And then this is the shrimp that the images of the fluorescent film for monitoring the freshness of the shrimp. And then this is the chemical interaction, chemical interaction between CDS and also UV with BAS. And also the this figure is about the application of smartphone-based device in food freshness monitoring. The second one is about contrasting literature and invention. Contrasting literature from this article, we can get some literature. The first one is biogenic amines or BAS are considered important biomarkers for estimating the freshness and quality of food quality. The second one, the utilization of carbon dots or CDS material as a fluorescent sensing platform. Lignin with high carbon content and abundant oxygen containing functional group as a suitable precursor for carbon-based material. So the invention from this article is the first one, an urgent need to find greener routes and materials to replace traditional synthetic substances and methods. And the second one is encapsulating CDS into cellulose nanofibers or CNFS and integrating it with smartphone so we can get the intelligent food packaging from CDS-based composite film. The advantages from this composite are simple, environmentally friendly, durable, sensitive, fast responses, and linear manner of intelligent food packaging from CDS-based composite films. The second one is about result and discussion. The first is characterization of lignin and CNFs from this figure. We can conclude that lignin solves similar spherical particles with different nanoscales. The hydrophilic units, such as hydroxyl and carboxyl functional group of lignin, extended outward, and the hydrophobic segment pennypropan structure migrated inward, resulting in a self-assembly of lignin molecules. The fiber structure of the liquid cellulose is partially degraded after deep eutectic solvents or DES pretreatment. Next, this is the figure of diffraction of X-ray and then infrared spectrum and also thermal stability. We can conclude from this figure are the diffraction peaks are seen at 2 theta values at 16, 22, and 34 degrees, corresponding to 101, 002, and 040 diffraction points of cellulose 1, respectively, indicating that the oxidation treatment retains the crystal integrity of cellulose. The infrared spectra of CFS and CNFS with carboxylic groups are shown that this compound retain the original chemical structure to some extent. Then the last, the thermal stability of lignin is also important to explain the relationship between its internal structure and chemical properties. Second is characterization of carbon dots. The first one, this is the figure about TEM. The 10 images of CDS are shown for RCDS of red, carbon dots, and blue, or BCDS exhibits spherical particle. This is the spherical particle. And then the high resolution 10 images of CDS show the typical crystalline structure. Next is about the powder X-ray diffraction pattern of the two CDS exhibit a broad peak indicating the presence of disordered carbon in the structure. The infrared spectrum shows that both CDS contain oxygen containing functional groups such as hydroxyl and carboxyl groups. Then the XPS surface spectrum reveals the existence of carbon, nitrogen, and oxygen element in the two CDS. This is the figure of XPS spectra that evidence that the CDS are always co-functionalized by strong electron donating groups such as hydroxyl and amine, and weak electron withdrawing groups, carboxylic acid. Number 3 is we can discuss about optical properties of CDS or carbon dots. From this figure, we can conclude that the UV absorption spectrum of red carbon dots exhibit a narrow band at 282 nanometer and a broad band near 535 nanometer, which are attributed to the P to P star transition of C-double-bond-C bonds in aromatic domains and to P star transition of surface functional group of red carbon dots. The luminescence properties of CDS in different solvents. The fluorescent intensity of red CDS in TMA, TMSO, and TMF reaches its maximum and also has good luminescence performance in methanol and ethanol with red-shifted emission peaks. In addition, the two CDS show very weak fluorescence in distilled water. Before we can discuss about the effect of pH and ions on carbon dots. From the pH, we can conclude that the pH sensitivity is related to various functional groups, such as carboxyl or amino group on the surface of carbon dots. The effect of different metal ions on the luminescent performance of the probe was investigated, and the fluorescent intensity of the probe decreased to some extent in the presence of Cu and magnesium. Number 5, we can discuss about detection of biogenic amines. From this figure, we can conclude that it is observed that red CDS have good sensitivity detection of biogenic amines and an excellent linear relationship in a short concentration range. This is the biogenic amine sensing mechanism of red carbon dots. We can conclude that the sensing mechanism of pH response is based on the protonation and deprotonation of surface functional groups of carbon dots, and also the carboxyl and hydrogen groups of red CDS may be deprotonated, which consequently induce the electrostatic or hydrogen bonding interaction with amine groups, resulting in the enhancement of red fluorescence. Okay, this is the number 7 about the application of CNFS as film for monitoring food freshness. From this figure, we can conclude that the result of the content of varying biogenic amines were consistent with the color change of the film, which proved that the film can be used for food freshness monitoring. The color of the fluorescent film changed from the blue to the red with increasing storage time, and the obtained light signal can be converted into the RGB value under the two channels of red and blue. The last one is about its personal implication to our proposal research. My proposal research is about synthesis of carboxymethyl cellulose based superabsorbent bioplastic modified with aluminum silicate compounds and its application as functional innovation of nutrient-rich artificial soil and pathogen antifungal. So from this article, I can conclude that this article give me the inspiration about the use of carbon dots from the biomass waste derived from biomass waste as a pillar for macro and micro fertilizer nutrient transporter was motivated me by this research. Okay, I think enough from my presentation. I think enough. Thank you and wassalamualaikum warahmatullahi wabarakatuh.